Hey everyone, welcome to Weekend Motorcycle Guys. My name is Aaron, and in today's video I'm going to be going through creation, not necessarily creation, but showing you the light mounts that I have made for my Triumph Scrambler 1200 XE. So I'll be covering some fusion progression. I will not be actually doing a live demo of me drawing that up, simply because I am not a expert in CAD software. I don't use it for my career or anything like that, so I'm pretty slow at it at the end of the day. If folks who are experts or utilize CAD software on a day-to-day basis, you might cringe at maybe some of the steps that I've done, but once again, I end up creating parts that that work for what I need to do, and so it might not be perfect. If you see something that can be done more efficiently, please share that in the comments. That's good for myself and also for others that are potentially trying to get into creating their own parts. Maybe they're interested in 3D printers and things like that, so that's a whole learning curve, and it'll just help them out, right? My main goal of these videos is to show folks you can create items for your bike that might not be available, right? Not all manufacturers or not all motorcycle brands have a large following of aftermarket accessories, possibly, and so we are stuck to create it ourselves. And this video will hopefully just help inspire others to kind of to do that. Other options, right, is just maybe there are parts, but they just available from aftermarket, but maybe they just don't really you don't like them, right? In my situation, the brackets that I have found, were off of just like Amazon, so pretty generic. They were pretty big and ugly, and also they didn't necessarily fit the fork tubes that well without having to add like rubber sheeting to compensate for that. Or in my situation, Denali does offer a bracket, but they're like $110. And since I have a 3D printer and I enjoy doing this stuff, I was like, I'm just gonna go ahead and print it myself and see what the outcome is. But with that, we'll go ahead and get started into this video. If you do like what you get out of this or gain out of this video, right, please like and subscribe to our channel. It'll help out Travis and myself as we continue to grow this channel. So with that, I'm going to go ahead and step into Fusion 360 and kind of show you the finalized product as well, because I've already printed it, and that'll be helpful from that aspect of it. And speaking of the finalized product, right, this is what I ended up printing, this portion here that you can see. Obviously I didn't print the light, but this is what I ended up making, and it serves its purpose quite well. And I learned a couple things during this, and I'm going to share the one thing that I had. I was tired when I actually started making this, so I had an oversight on one thing, and what that was is that obviously we have a rake on our motorcycles for that front suspension, and when I designed this and made it up the first time, this tang right here that this light sits on was actually in line with the top of the bracket itself. So when the fork tubes do go through this portion of it, that tang was also at this angle too. What that caused is that I had to compensate for this light. I had to move it downwards to get it parallel with the ground, and when I did that, it was almost hitting this bracket, so it didn't give me a lot of adjustability to go down, point it more down towards the ground and things like that. So I had to go back to the drawing board and create this tang to be parallel with the ground while still allowing the bracket to compensate for the rake of the front suspension. So that was my one learning opportunity in that situation. The way that I ended up finding out, the rake of that front suspension is just using Google. and seeing what that came out to being. It was like 29.6 degrees. I just rounded to 30. I also kind of did a sanity check, and what I ended up using was just a digital angle gauge. I've had this because I do some woodworking sometimes, and so for my miter saw, to get my angles just a little bit more precise than what the saw has for predetermined stopping points, I had that gauge. I think I maybe spent $30 on that. And then also, if you are just kind of getting into design and 3D printing, you're also going to end up getting just a set of digital calipers. I got these from Harbor Freight. Yes, they're cheap, but they do the job. Right, we're just 3D printing some functional components for the motorcycle. If you're a machinist and you see my Harbor Freight digital calipers, I understand there's better ones out there and everything like that, but for this purpose, they're sufficient, right? Beyond that, that's really kind of just some of the basic tools that I use. I may use just a simple steel ruler as well. That has both imperial and metric measurements onto it. Once again, it's, this is a cheaper ruler, and it's stamped, so you could have some fluctuations in those measurements, but it does work for my usage. So sit back, we're going to jump into the actual fusion aspect of this right now. Maybe we will. There we go. All right. So what you should be seeing now here, obviously, is a blank screen, and in this right here, I'm just gonna go ahead and click through the progression of this build. In the lower left-hand corner, you're gonna see the generic kind of backup button, a play button, and then like move forward through that, like a fast forward button. And there's a caret key here on the bottom left as well, and that's kind of the play-by-play marker. When I started out with this, what I ended up creating was just simply a rectangular cube, and that is ultimately the tang that the light sits on for the bracket itself. The following steps is just simply a creation of this plane here. This blue box, or this blue square you see here, is a plane that I inserted at an angle, and that angle represents what that rake of my front suspension is. From this, I start building the actual bracket based off of that plane itself, which we'll see here pop up in just a second. So once again, this tang, when it's mounted to the bike, this is parallel, this little black bar that's highlighted, that's parallel to the ground. That's what you want to have. And then obviously this bracket that's at an angle, that's where the front suspension, the fork tube will pass through. So that works out pretty nice from that. And as we progress through this, what you're going to see is me actually just going ahead and minimizing the overall height of that bracket. I wanted to reduce it. I didn't want it, super big or anything like that. So that's just me kind of getting that matched up a little bit more and things like that. Following steps here coming up are just going to be adding the hole for the light itself, right? That is just where that bolt from the light bracket itself mounts to this tang. And that bolt is only so long. This particular tang was too thick, so I have to remove a bit of material, so that way the bolt itself can pass through that, and I can use the nut to attach it to that tang. Following steps is just kind of cleaning this up here a little bit. I ended up going through and putting, removing some extra material and getting an angle on here to still provide support for that light as it gets further away from the bracket itself. And then the following steps here are going to be actually adding in a fillet to these, to some of these very sharp corners, these 90-degree corners. While it would likely be sufficient for strength, adding a fillet does help add additional strength into it and support, reduces that risk of a stressor kind of occurring at those 90-degree bends. Following fillets here, you'll see will start kind of being on these exterior edges, and these aren't adding necessarily any strength. It's rather just reducing the ability for this plastic to cut you if you catch your hand on it or something like that. I added some fillets here along these edges. Once again, this is where this is actually joining to the bracket, so I wanted to add just some additional strength. The next one we'll see here will be where this black bar is highlighted on the screen, and once again, that's just to help with strength. Following fillets will be around this edge here on the exterior of it. Once again, that's just simply to help reduce the opportunity to cut yourself on those. Following steps here are going to be adding in the holes for the bracket itself, right? I want to be able to add, to affix these two pieces together once I start getting the other half printed up or made up here. And you'll see these populate right now, adding some additional radiuses in here as well for strength here. And then the following radiuses will be here on these corners that you can kind of see that little light bar highlighted here. I'll zoom in just a bit, but it'll be adding just those radiuses in there just to protect from cuts and things like that. At this point, essentially that portion of the bracket's complete. Now I needed to make the second portion that would clamp onto the back half of that suspension, and that's going to be showing up here in just a moment. And you can see that's where I started creating that second portion of the bracket. Once again, not an expert in CAD, likely an easier way to do this, but I'll end up extruding this bracket down to match the same height as the first portion of that bracket, and then ultimately adding in some more fillets just to match it so it's the same. And then the following steps will be just getting the bolts holes on this plane here, right here, that's highlighted, and also this one right here. So you'll see those pop up here in just a moment, and there they are. From this point on now, right, the bracket is essentially complete. I will export this into either an STL or a step file without getting too much too much details on that. The STLs can be just a little bit more rough for circles because of how it processes the code for that. A step file will help keep anything that has a radius onto it more true to being a radius itself. With that, we'll step into the software that I utilize to slice this component for the 3D printer itself. Alright, so now this next portion here is going to be the slicer. This slicer that I use is from Bamboo Labs, so it's called Bamboo Studio. This is specific to a Bamboo printer itself. Other slicers will do similar functionality. It just depends on the printer that you have and if there's a proprietary slicer that's utilized with that printer. You can use other slicers such as Orca or even I think Cura as well for a Bamboo printer. You just have to save that G-code file to an SD card and put that into the printer. If I continue to use the Bamboo Studio, I can send that to the printer wirelessly, so that's why I just stick with the Bamboo printer or the software itself. So yeah, so with that, we'll just jump into the actual kind of some of the things that I end up doing with this, right? Once I import this portion of the bracket, it comes in just oriented this way. I'll end up using the auto orient from the software itself. It's likely doing this to help save or reduce the print time and everything like that. Some watch outs, if you're not familiar with 3D printing, you have 3 planes of access. You'll have an X, Y, and Z plane. When you print items that have you know, they obviously are going to go up towards the sky. So this blue arrow here in the bottom left hand corner, that's your Z plane. That is the weakest of the 3 planes for printing for strength. So depending on what you're printing, if it breaks, you may need to reorient your part on the build plate a different way to help with strength. In this particular situation, this is very strong, you know, even with the Z axis and this height this way. I ended up sticking with a 0.2 millimeter layer height. The bamboo printer that I use is the P1S. It's got great quality at 0.2 millimeter layer height for me, so I don't need to reduce it down to something smaller to help achieve the detail that I like. Because I'm printing this as a prototype part, I'm using PLA, so you know, it's a lot cheaper than some other materials and things like that. And since it's a prototype part, I've reduced ultimately the amount of wall loops that I use, and even the infill percentage, just to save on material and print it faster so I can test the functionality of the part. Once I get to printing the final product, I'll actually be switching to a PA6CF filament, which is going to be have more robustness to in comparison to like the PLA material. It's going to be stronger, it's going to be better for the weather and things like that. And once I do switch to that, I'll actually be adding in more infill density to just add some more strength to it, and also increasing my wall loops, likely just by 1, so I'm going to go from 3 to 4. Other aspect of this is that because this tang that comes off of the bracket itself is not touching the build plate, you'll want to add supports. I run a tree support. It uses a little bit less material, and I think it does a better job than the standard default support that most folks, you know, that was originally used. If I slice this right now and you guys see the final outcome here, the orange is going to be the bracket itself. This green portion are those supports, and you can see they look like trees, hence them being called trees. The support itself just gives those overhangs, you know, the things that aren't touching the build plate, something to rest on as it's being printed into the air, essentially. If you don't have that, you can run the risk of the print failing and not having good overhangs. And just to kind of show you the difference between the trees and the normal supports look like skyscrapers, and you can see that. You can see there's just quite a bit more material all utilized throughout that. So yeah, so once we go ahead and slice that, I can send that to the printer and it will do its thing. It'll print it up for me, and that would be essentially, you know, the conclusion of this. One thing I'll talk about just real quick here, coming back to this, is that, you know, the lights, I didn't really say anything about the light that I end up using, and I'll have a separate video for that as well. But this is just the KC Flex Era 1 pods, so it's just one being just a singular light beam itself. They have like I think like, you know, Flex Era 4s, which would be 4 light pods, so light bars for vehicles and stuff like that. Good thing about these lights, just really quick, is that they come with different lenses, so you can switch between like a spot, a flood, and like a wide beam pretty easily. And I end up going with these lights just because I like the smaller footprint. I have utilized the prior version of the Flex or the KC pods. They changed it. I think they were originally just called, they might have been called the Flex Eras. I'm not sure, but they had a prior version, and I just liked it, so that's why I stuck with that. But with that, that essentially concludes this video. Pretty relatively short, and you know, if you liked it and you got some good content out of it, please like and subscribe once again. If you have questions, put those in the comments. Be happy to try to answer them, point you in the right direction, or provide, you know, my advice. Once again, I'm just kind of a general guy, just doing this stuff because I like to tinker and everything like that. Following portions of this video will just be the 3D printer itself. There's some small little clips showing it being printed and everything like that, and then just ultimately the lights themselves being mocked up onto my bike. Once I get the more of the finalized version, I'll also have another video going through showing kind of the final setup and everything like that. Probably doing some wiring and things like that, as the KC lights are normally used on, you know, Jeeps and things like that, so the wiring harnesses are really long. I'm going to reduce that because there's not a lot of room on the bike, so I have to do some wiring and everything like that. So I'll work on another video coming up going over that, and yeah, we'll see where we get with it. So once again, thanks for watching. Hope you enjoyed it. Till next time, we'll get another video up for you here hopefully soon. Thanks.